not as much. The other equations we're going to deal with are work. Work is equal to force times distance, and the force has to be parallel to the distance. So if it's at an angle, it's FD cosine theta, because that's the horizontal component or adjacent side. Okay. Power is going to be work divided by time, or force times, not distance, force times velocity. Either one of those gets you power. Because, well, we'll get there.
That's a V, right? Velocity?
Mm-hmm.
Okay.
Here's the thing, the only way we get a change of kinetic energy or a change of potential energy is if we do work on the object. So you can say that the work put into an object gives you a change of kinetic or a change of potential. So if you're going to change potential energy, you have to do work on it, okay? So this is called work energy theorem. And so we're gonna use this a little bit too. We're gonna talk about this a little bit tomorrow. So if you're going to be absent tomorrow, I'm hoping to do some recording tomorrow in class as well and put some of this out there, okay? All right. So the main things to talk about today, potential, kinetic, and we're not going to worry about this one so much, but these two, okay? So let's look at a ramp like this. Okay, we have a ball sitting on a ramp, okay? It has an unknown mass. We let go of this ball and it starts at rest, so the initial velocity is going to be 0. If I want to know the final velocity, anybody have an idea of how we can do that?
Find the acceleration.
Find the acceleration.
Well, we find the distance it covers using a trig function.
Okay, so we could find this distance using a trig function.
Yeah.
Okay.
And if we,
And
If you find the distance.
Kobe
you
said
use
the
first.
acceleration, right? So distance, acceleration.
If you find the distance, can't you just use the first one?
If you find the distance, can't you just use the
Like the
first?
change in x, like the first.
Okay, so if you know this and you know that, and we know this, then we can get that, right?
yeah.
Okay. All right. So how would we get then the acceleration? Somebody said something about time also. What's that?
Gravity.
Gravity. What direction is gravity accelerating?
Yeah.
Down at
Down.
9.81 meters per second.
Yeah. Gravity's acting down. So if it were falling straight down, it would accelerate 9.81 meters per second squared.
But it's not, so you
It's
find
not.
it.
So we have to find the acceleration. So is it as much or less?
It's gonna be less.
Or it's less.
Right? Yeah, less because it's at an angle.
So you think maybe we could take and use a little bit of trig and find if we said the acceleration this way is 9.81 and we took the angle here, we could find the acceleration going that way, just like we did before with forces and Newton's laws.
Yeah.
And then we could use this height and the angle, we could get that distance, right?
Yeah.
And we get a final velocity. Am I seeing that?
There you go.
Okay, there's an easier way. What type of energy does it have here?
Potential.
What type of energy is it gonna have here? How much of the kinetic will have been potential?
All of it.
How much of the potential becomes kinetic? All of it?
So
Okay.
mass times gravity times height equals 1/2 mv squared.
Yeah.
Impressive.
So mgh equals mv squared over 2. Okay? So then, if I were to take and work this out then,
That's
okay, if I'm gonna try to get velocity, what do I do?
Multiply by two.
Multiply both sides by 2. 2 mgh equals mv squared. Then what?
Divide by n.
Divide by m. So if I divide both sides by m, that cancels out, right? 2gh equals v squared.
Square root.
Square root.
Also